If you're like me, when you're thirsty, you run to the kitchen, but take a second to decide whether just to grab a glass of water from the sink, or go over to the filtered water from the fridge, or to just grab a can of sparkling water and wonder, is there really any quality difference between these? Well, today let's test the quality of tap water, that's pulling water from a water softener, filtered water from the fridge from an 8-month-old filter that's also coming from the water softener, filtered water using a brand new water filter, sparkling water, and finally distilled water. Now, before we start, we'll be using two different metrics, TDS and EC. TDS stands for Total Dissolved Solids, which measures how many particles like salt and metals, minerals, and ions like calcium and magnesium, chloride and potassium, lead and iron, and sulfates, which are dissolved in the water. TDS units are measured in ppm, or parts per million. The standard maximum is 500 ppm, so anything higher than this is just considered not safe to drink. Now, EC, or electrical conductivity, is also an important measure when checking water quality, as it measures the fluid's ability to conduct an electrical current due to the dissolved ions present, like sodium and potassium and calcium. But EC alone is not enough, as, like, for example, suspended clay or hydrocarbons or organic material does not conduct electricity. So you need both EC and TDS. Now, the standard units for EC is microsiemens per centimeter. So anything below 800 microsiemens per centimeter is considered safe and good quality water. Okay, well, first things first, we should measure the temperature of each of these cups of water, and the reason why is because temperature affects the EC number. The higher the temperature, the greater conductivity, believe it or not. And typically we want to be at 25 degrees Celsius, but as long as each of these are the same, as you see here, we have 18.8 degrees, 18.7, 18.3, 18.2, 17.8, 17.9, and finally the distilled water, 18.0. All right, well, let's get started here, and we'll start with total dissolved solids measured in units of parts per million. And let's do the tap water here, and you see how that just instantly turned red. Right now it's at 0. This is tap water, and the moment you drop it in, and we are reading at 318 parts per million. That's tap water. That number isn't good, but at least it is below that 500 parts per million standard number. Now let's take this filtered water. This filter is from March of 2024, so about, say, 8 months or so. And let's just see what it reads. So here we're reading at 315. What's crazy is that this next one, you can even see the color difference. This is the new filter. And when we put this in, brand new filter, this is reading at 393. So this is even higher than the dirty filter. Why is that? Well, the first amount of water that I pulled from the new filter was actually at about 1,000 parts per million, maybe even more. And that's because of the particles, maybe from the manufacturing, possibly carbon particles. And this water right here, it's reading about 400 parts per million. I actually pulled out about 8 gallons of water. And so for every gallon of water, it dropped from like 1,000 parts per million to 900 to 800 to 700 to 600. And so now after about 8 gallons, I would say, that I pulled from the fridge, it's now reading, 398. And I am going to assume as we continue to pull water from the fridge, that number hopefully will continue to go down, because that's still quite a high number, especially for it being not only filtered water but also soft water. Okay, next up we got sparkling water, and this is just a bubbly. There's even a little bit of sparkling still in there, a little bit of bubbles. Let's see what this reads. Drop it in, and we're reading at, look at that purity there, 23 parts per million, which is, until now, we haven't seen anything under 100. That's sparkling water for you. And finally, distilled water, which we shouldn't drink. We can, when you go and grab a gallon, you grab the drinking water, not the distilled water. You can use that stuff for ironing or whatever. Distilled water at 3 parts per million, which is essentially pure water. And there you have it. There is your TDS for those 5 waters. Now, if we move over to our EC, let's read them again. Here we go. Tap water. Let's do it again. Tap water instantly turns red, and we are reading 626 microsiemens per centimeter. 626. That dirty filter, that fridge water. So we go from 626. Looks about to be about the same. 628. Old filter. New one, even higher, which makes sense because that was the highest number even with the TDS. 798. Sparkling water, what do you suppose is gonna pop up? Definitely gonna be a lot less. We have 50 microsiemens per centimeter, and that makes sense because there is very little electrolytes that is allowing for that electrical conductivity, and that's why there's those 2 probes on the meter there. And finally, distilled water, we are at 6 microsiemens per centimeter, and there you have it. So distilled water and sparkling water are by far the most pure, have the least amount of solids floating around, and have the least amount of electrolytes like calcium and sodium and chloride and potassium. And my guess is that, you can even see, even after 8 gallons, if I were to hold these up, you can probably even see in the camera that the one on the right, the new filter, is even dirtier. You can see the water is not as clear even after 8 gallons. It did come down quite a bit, but I'm just surprised that it's taking this long. And so there you have it. Now, those are 2 tests, TDS and EC. Now, there are more. There are other measures as well. There are more measures. For example, you have pH. pH is important. But those 2 are 2 very typical tests that we use for water quality. Thank you guys very much. All right, well, that's it. Thanks for watching, guys. Hope you learned a few things, and we'll see you in the next one.